Good morning, learners. Our subject for this morning is Science 5 for Quarter 3, Week 1. And our topic is measuring motion in terms of distance and time. And at the end of the lesson, you are expected to describe the motion of an object by tracing and measuring its change in position over a period of time. Look at the picture and let us answer the questions. For number one, what does the children do in the picture? Okay, very good. The children are playing. Number two, do you know what traditional Filipino game they are playing? Yes, you're right. That is tumbang preso. Do you experience to play tumbang preso with your friends? Okay, that's good. Number four, what are you going to do in order to win in the game? You should use slippers that are not heavy. You should know how to target the aim. You should run fast so that you will not be touched or chased by the taya. Number 5, do players need to move while playing the tumbang preso? And why is it important to move around and let the team be fell on the ground after it was hit by the opponent player? To avoid from being tagged or chased by the opponent player. Body movements in any games are necessary to play the game properly and of course to win the game. Motion and energy are relatively important in our daily life. Motion and energy work together to make things easier for us. Through the help of force, motion can be achieved. Without motion, we cannot do work and enjoy life. Life is so boring without any movement or any motion in it. But what is motion? Motion, by definition, it is a change of position with respect to its reference point. A reference point is a fixed place or an object used to determine the position of the object. The activities that you are going to perform will clearly describe what causes the object to move and measure the distance covered by a moving object which is affected by its speed or the measure of how fast it moves. So for letter A activity, prepare the materials listed below. If not available, you may use the other materials at home to perform the activity. You may ask the help of your parents or guardians or any adult members of the family if needed. And the title of the activity is Movement and Motion. And the materials are small ball, notebook, large hardbound book, masking tape, toy car, ruler, and marker pen. And the procedures for number 1, mark a spot on the floor with a masking tape. Label it as point A. Number 2, place the small ball on point A, then blow on it. Number 3, using a ruler, record the distance in centimeters if the ball moved away from point A or if did not move at all. Number 4, place a toy car on point A, then blow on it. As much as possible, apply the same amount of force applied on the ball. Using a ruler, record the distance in centimeter if the toy car moved away from point A or did not move at all. Number 6. Place a notebook on point A, then blow on it with the same amount of force applied on the ball and the toy car. Number 7. Using a ruler, record the distance in centimeter if the notebook moved away from point A or did not move at all. And number 8, repeat steps 1 to 7, but the ball is time. But the ball is time. Push the ball, the toy car, and the notebook with your fingers. Record your observations. Number 9. Repeat steps 1 to 7, but this time use one side of the hardbound book as a ramp, 45 degrees inclination. Label its highest point as A, and then put the ball, toy car, and notebook one at a time without applying any force. Observe what will happen to the ball, toy car, and notebook, and then record your observations. And number 10, make a table like the one below to record your observations. Put a check mark if there was movement after force was applied. So we have 4 columns, and the first column is objects to be moved. So we have the ball, toy car, and notebook. And for the second column, we have blowing. The third column, we have pushing. And the last column, we have placing on a ramp. And then you will answer the following questions. Number 1, which action causes all the objects to move? Number 2, why do you think this action causes movement? Number 3, which among the objects is the hardest to move and why? And number 4, which among the objects is the easiest to move and why? And number 5, what is the importance of point A in determining the movements of the objects? And for letter B, prepare the materials listed below. If not available, you may use other materials at home to perform the activity. You may ask the help of your parents or guardians or any adult members of the family if needed. And the title of the activity is Measure It. And the materials, we have 3 books of equal thickness, marble, 2 rulers of the same size, metric, and tape measure. And here are the procedures. Number 1, position the rulers together on a book with a distance from each other that would fit a marble. The rulers would serve as a ramp for the marbles. Number 2, release the marble between the rulers. Measure in centimeters the distance covered by the marble. Take note of the time in seconds as the marble travels. Number 3, repeat steps 1 and 2 for trial 2. And the number 4, put another book on top of the first book. Repeat the steps 1 to 3. And number 5, put another book on top of the 2 books. And then repeat the steps 1 to 3. And for number 6, record your measurement in the table in the next page. And here is the table. So we have 3 columns. So for first column, we have 1 book, set up A, 2 books, set up B, and 3 books, set up C. And for the second column, we have trial 1, the length traveled by the marble in centimeter. And then the last column, we have trial 2, the length traveled by the marble in centimeters. And then afterwards, you are going to answer the following questions. For number 1, what setup resulted to the shortest distance traveled by the marble? And why do you think the marble traveled the shortest distance with this setup? Number 2, what setup resulted to the longest distance traveled by the marble? And why do you think the marble traveled the longest distance with this setup? And number 3, how can measuring distance help us in comparing things in motion? And number 4, What is the effect of height on the distance a marble travels from a ramp? And number 5, what is the speed of the marble in trial 1 and 2? Remember, pull or push as part of exerting force may also relative on the distance on the object when it is moved from one point to another. However, distance is the measure of how far or near two points are from another. It can be measured using different ways such as time, landmark, or body parts. This time, let us discuss distance. Distance is measured by using tools such as meter stick, measuring wheel, and ultra distance measurer. So we have the meter stick, the tape measure, measuring wheel, and the ultrasonic distance measurer. On the other hand, the distance covered by a moving object is affected by speed, or the measure of how fast it moves. Speed of an object can be calculated by dividing the distance covered by an object in motion by the time spent to cover the distance. And we have this formula. Speed is equals to distance covered divided by time, or S is equals to D over T. For example, Jairus traveled 5 meters away with her bike from her house going to Plaza in 120 seconds. So in getting the speed of Jairus' bike, following the formula stated above. So we have the speed is equals to 5 meters divided by 120 seconds. So the speed is equals to 0.43 meter per second. So the speed of Jerry's bike is 0.42 meters per second from her house to the plaza. For the engagement, for letter A, name at least 5 of your daily activities and describe how motion takes place. So here is the table. So on the first column, we have the activities involving motion. And the second column, how does motion takes place. So number 1 is my example. So the first activity is walking. So how does motion takes place? When we walk, we change our original position to the place where we are going. So you have to take down at least 4 of your daily activities or even 5. For letter B, analyze and solve the problems. Then fill in the table with the needed information. So here are the table. So we have for the first one, the first column we have the problems. The second column we have distance. And the third column we have time. And the last column is the speed. So for the first problem we have a cyclist travels 200 kilometers in 8 hours. What is the speed of the cyclist? So the distance is 200 kilometers. The time we have 8 hours. And the speed is 25 kilometers per hour or 6.94 meters per second. For number 2, a mouse runs a distance of 2 meters in 15 seconds. What is its speed? So for the distance, we have 2 meters. And for the time, we have 15 seconds. And what is the speed of the mouse? So we have 0.13 meters per second. And for number 3, a car travels 300 kilometers in 5 hours. What is its speed? So the distance is 300 kilometers. And then the time is 5 hours. And then what is the speed? 60 kilometers per hour or 16.67 meters per second. For number 4, A man runs 108 kilometers in 3 hours. What is his speed? So the distance is 108 kilometers and the time is 3 hours and the speed of a man is 36 kilometers per hour or 10 meters per second. And number 5, a tricycle drove to a passenger's house that is 20 meters away from the station in 10 minutes. What is the speed of the tricycle? So the distance is 20 meters. The time is 10 minutes. So the speed is 0.033 meters per second. So that is the answer for letter B. Okay, for the assimilation, remember that in describing the motion of an object by tracing and measuring its change in position over a period of time, you need to take value of the importance of having a standard unit of measurement in determining the distance between 2 points. So knowledge in conversion is also necessary to get the speed of a moving object. So let us take this word problem. My Santa's family always get together during weekend. They plan to go to Tagaytay with their new Toyota Rush. Tagaytay is 70 meters away from their home and they tend to get there in just 35 minutes. What will be the speed of the car needed to land in Tagaytay? So let us solve. So the given are, we have the distance is equals to 70 meters. The time is 35 minutes. And the speed is what we are going to answer. So we have the formula. S is equals to D divided by time or distance covered divided by time. So here is the solution. So S is equals to 70 meters is it over 35 minutes. So you have to convert the minutes to seconds. So that will be 35 times 60 is equals to 2,100 seconds. So this now will become 70 minutes or 70 meters over 2,100 seconds. So the answer is the speed is equals to 0.33 meters per second. So for the assessment, read the questions and encircle the letter of the best answer. So for number 1, a change in an object's position is called A. Force, B. Motion, C. Pulling, or D. Pushing. The answer is okay, letter B, motion. You are correct. Number 2, how do you know if an object has changed position? A. It is not visible anymore. B. It looks bigger. C. It is farther or closer from a reference point. Or D. It is on top of a reference point. The answer is letter C. It is farther or closer from a reference point. Number 3, forces have both blank, a magnitude and speed. B, direction and speed. And C, magnitude and direction. The answer is magnitude and direction. Okay, so let's move on to number 4. The distance traveled by an object per unit time is called blank. A, velocity. B, speed. C, momentum. D, acceleration. And the answer is speed. Okay, number 5. The property of an object that resists change in its motion is blank. A, mass. B, inertia. C, velocity. D, momentum. So the answer is inertia. Number 6. A force that resists motion created by objects rubbing together is blank. A, gravity. B, friction. C, speed. or D, force? The answer is okay. So the answer is letter B, friction. Number 7. A force that pulls objects towards each other is blank. A, force, B, frame of reference, C, gravity, or D, kinetic energy. The answer is letter C, gravity. Number 8. An example of balance forces is blank. A person skating back and forth on an ice rink. Letter B. A tire with treads gaining speed on an icy road. Letter C. Two soccer players running in opposite directions. Or letter D. A book resting on a desk. So the answer is D. A book resting on a desk. Number 9. A force that sets an object into motion is blank. A, balanced, B, friction, C, unbalanced, or D, inertia. Okay, so the answer is letter C, unbalanced. And number 10, velocity is a measure of speed that takes into account the blank. A, weight of an object, B, direction of movement, C, force of the movement, or D, acceleration of an object. The answer is A, weight of an object. Okay, class, did you find it easy? Okay, so well done, children. For the reflection, so reflect on what you learned on this lesson about measuring motion in terms of distance and time. The part of the lesson I believe I learned most about is blank. The task which I found most challenging is blank because blank. I realized that I can use what I have learned from this lesson when blank. And that concludes our lesson for this morning about measuring motion in terms of distance and time. And that's all. Thank you, children.